So what we're doing is a biome exploration station. This is station number 1, and we place pictures of different biomes in the correct area. Top being cold, top of the pyramid being cold, bottom of the pyramid being hot. So the top will probably be like Antarctica or something like that. The bottom will most likely be the desert. And then this is the tundra. Let's put on this. Oh, gonna be like a
So let's think of things in the tundra that we found a lot. What do you know about the tundra? Okay, now it's time for
Wait. Is this Fernandez? You said there's a hot.
well, okay. So
is this the right move?
I'm gonna help you out with the. All right. So we said the desert. What do we know about the desert?
There's a hot.
It's hot. Wait, it's hot, and some of the deserts are hot. So we're gonna have one. All right. So let's say we had the hot desert. Is the desert moist or dry? So would you say it's the driest? So we will put it over here. What about the tropical rainforest? Is that hot or is that cold or medium?
Probably medium.
Okay, we're gonna say towards the warm climates, right? Because it's close to the equator. So is it wet or medium wet or very wet? Wet. So I start you up by giving 2 more. Okay? So we have the tropical rainforest here in terms of wetness is the most moist, and then in terms of dryness is the desert. Okay, so now you have to work on it. I will let you know that.
Seeing how different animals adapt to each environment. So we have different hands going into ice buckets with different materials. Here you can see blubber, here is cotton, and here is feathers. And we also have a normal hand and just a normal plastic bag. We're going to have each person put their hands into the ice bucket and see how long they last. And we're going to see how each material will last throughout, well, of course, the tundran biome, and see which material will last the best.
Remember that you're recording how it felt. So as you record your data, because remember that 4 minutes ago, so just record how you felt.
We're going to dissect the organisms that we have and observe the adaptations that they have so that they are...
What was the button? This is fine, right?
Oh, that's like...
Oh, that's nasty.
Oh, it's turning on.
It's attached. Oh, that's nasty. So what else is it?
Wait, video, what is
That's nasty. Identifying the plants, and then we're sketching pictures of them, and we have to then see what factors inside of their habitats are maybe affect their growth, and see, I guess, how they ended up this way, because sometimes some plants will branch out in different directions based on the environment that they're living in to get like more water and stuff to survive.
All living things need a specific.
I was the one who found this.
Where do they get their energy from?
So weird.
The sun.
The sun. Is that living in a
I thought it was something because you'll be able to share.
Because at the end, as a team, you're going to have to tell me which chromograph goes with what line.
So obviously, because it's 1.1 inches per month.
We learn differently in here because it's a lot of hands-on stuff. We're not like reading through textbooks. We just yesterday we went outside and looked for producers and consumers. So it's very hands-on in here. Right now we're actually doing research for a project that's having us recreate the famous biodome experiment. Right now we're trying to decide what biomes we want in here by, deciding like, oh hey, what's the temperature here? What's the average precipitation? So it is research, but it's a lot of fun and hands-on stuff as well.
So you want to have this and your side by side.
So our question for our students is, how do you survive with limited resources? So in our combination biology language arts classes for 9th graders, we've been helping them to learn about how humans are running out of resources and how this is a problem in our world. Their task is that as engineers and biologists, they are designing and marketing a biosphere that could help to save the humankind should we run out of resources. So they've been going through the research process the last several weeks. They've picked animals and plants so far that to include within their biospheres. They've also chosen which biomes. And also today we are Skyping with a biologist from the Gwinnett Heritage and Environmental Center so that our students can ask further questions in regards to what they need to include in their biospheres.
At fairly complex systems, but obviously your major source of sequestering that carbon is going to be through plant biomass. And so you're going to be looking at having a high amount of plants covering your land surfaces. And that's really going to be in any of your ecosystems that you're looking at. Obviously, you guys know probably that plants take in that carbon as part of their respiration and photosynthetic process, and then they produce oxygen, which is what we need, kind of as the waste product from that. And so the more plants you have, the more carbon you're reducing out of the atmosphere.
Now again, I wanted to ask, do you have any tips on making an artificial environment like the sun and heat and oxygen in the biosphere?
Sun and heat and oxygen. Oh boy.
Tough question.
Well, I can give you an example of a project I did when I was in high school.
Okay.
My environmental science teacher had us take about a gallon jar, clear, and we had to create a miniature aquatic ecosystem inside of it. And so it was up to each of us to research how much oxygen we wanted in there, how much water we wanted in, and what kind of plants we were going to, plants and animals we were going to put in there. My project ended up lasting the longest, which was kind of fun. But it's really all about thinking about that oxygen exchange and the carbon dioxide exchange. So you want to have some atmospheric oxygen that can be infused into the water and taken in.
In your journal, I should be able to get almost like if you were engineers and you're giving me like a two-dimensional design or like a plan of what your forest looks like or what the area of your forest, your area in the forest looks like. So you're going to tell me where the grasses are located, like how far from the road are the grasses located? How far do you start to see shrubs? When do you start to see pine trees? When do you start to see the more mature forest? So you guys are going to record it. So today is basically recording. But I want you to keep in mind some things, and you're going to write this in your journal. So for example, if you, how far is it, like do you see a lot of light in this section, or is this area shaded? Do you see any insects? Do you find any moss? So as you're recording what you see, you're going to keep track of everything, both the flora and the fauna in the area. Taking the edge off, alright? And we're going to go from here. And you're going to keep track, and you're going to need 2 people counting and 2 people recording. And then when you're done, you're going to sit down here and you're going to illustrate your forest, your area. Look at me over here. So you see at the bottom, I gave you kind of like what the dominant flora should be. So you see how stage A is only grasses. So you're going to identify where is stage A. Where do you see only grasses? All right, well, how big is that area of only grasses? Okay? Then you're going to find stage B.
I did like...
Put it down.
That's okay.
Drop down.
We're not reading on the
Guys,
Yeah, that's
the idea, guys, more important than the size.
3.1 meters is group grass area. 3.1 meters is grass area.
So if you know that each box is a meter, you might want to say like 3 meters out. Okay, so you know that. Okay, so we're keeping track of where the moss is located.
Do you draw it?
Right? You can illustrate it as like flat green and then just put moss.
In today's day and age, there is a drastic resource depletion problem. Icebergs in Greenland are rapidly melting. This will lead to great amounts of flooding and resource depletion through this. And seeing the rising need of this problem, we've decided to create a solution. So our idea was to create a self-sustaining, protected livable space in the event of resource depletion. We want to provide a living space for a family of about 4 to 6, with biosphere starting from 0.005 square miles and going up to 50 square miles. It's great customization. We actually want to sell these things to people and get your money back if you do indeed decide to invest in us. We wanted to have Antarctica purely for lots of reasons. Our water filtration system is one of them. With the cold climate there, it's naturally cold there. So when we dig under and put a stainless steel box that will take salt water, unfiltered, from the oceans, then we will heat them with our heating from our electricity, which will be explained later on in the PowerPoint, creating convection currents. This will keep the water moving, and when we decide we need water to filter, opening will open up, and it will be forced through a membrane, filtering out all the impurities like salt or any chemicals that are in there, making it drinkable for all of our biomes.
The second biome we decided to include in our biosphere is the temperate forest. We chose this biome because we live here, know how to sustain it, and know a lot about the plants and animals in the biome. We focus mainly on keeping the soil extremely rich in nutrients because this is where all of our food for the community is going to be grown. Some of the plants here can also be used for food and medicine, and to ensure that we'll be able to continue building things and have extra tools, we included plants that are good for construction.
The water biome contains different forms of water such as lakes, rivers, etc. Rather than having the two connect the water biome with the city, a river connects the two together. To avoid hazards of flooding in the city, we included a saltwater marsh at the end of the river and in the front of the diagram. It shows how exactly the river and marsh are placed. Now, we place the marsh there to prevent overflooding, but also to be a source of salt in our biosphere. Near our biosphere is the ocean. The ocean is not a part of our biosphere, but we use tide energy with buoys from it to provide a source of energy for us to use.
So this is the farmland over here, so since it's like right, we wanted to put all the biomes like right on the river. That's why we made it going across, so like it's easy to.
And these have been the two villages,
Yeah,
so they can each,
right.
there's a total of 40 people.
There's gonna be like, we don't want to have too many people, so there's like 20 people on each side,
Okay.
so that there's more water and resources to
And how big of a space is this?
I wouldn't say too big, because it's only gonna do like it's only gonna hold 40 people, so it's not gonna be huge. Just big enough to sustain